Mule tape offers several benefits for wire pulling. Firstly, it provides easy pulling. Mule tape is pre-lubricated, reducing friction and making wire pulls smoother. Secondly, it offers durability. With a breaking strength of 1200 pounds, Mule tape is less likely to break or burn through elbows during the pull. Thirdly, it is very versatile. The tape can be looped over anchor bolts, making it easier to pull from difficult angles. When comparing Mule tape to polyline, Mule tape pulls easier due to its pre-lubricated surface. Mule tape is also more durable and less likely to burn through during the pull. Polyline can be more affordable, but its disadvantages often outweigh its cost benefits. Consider a specific example. In a 180 FD wire pull using 32/0 aluminum XHHW conductors and polyvinyl chloride conduit, Mule tape was found to be superior to polyline. The tape looped effortlessly over a pull anchor bolt, making it possible to pull down from a height. For wire pulls where ease of pulling, durability, and versatility are important, Mule tape is a highly recommended option. It is a superior choice to polyline, especially for pulls with multiple conductors or difficult angles. When performing electrical work, always consult and adhere to relevant safety standards such as those outlined in the National Electrical Code or NEC. These standards ensure safe installation practices. For example, Article 300.14 covers the length of free conductors at outlets, junctions, and switch points, while Article 310 addresses conductors for general wiring. Understanding conduit fill calculations, as detailed in Chapter 9, Table 1, is crucial for ensuring proper heat dissipation and avoiding conductor damage. Select the right type of conduit for the application. Electrical metallic tubing or EMT is a common choice for indoor applications, while rigid metal conduit or RNC is suitable for outdoor or harsh environments. PVC conduit is lightweight and resistant to corrosion, making it ideal for underground installations. Each type has specific installation requirements and support intervals, as specified in Article 358 for EMT, Article 344 for RMC, and Article 352 for PVC conduit. Correctly grounding and bonding the electrical system is essential for safety. Article 250 provides detailed requirements for grounding and bonding, including the size of grounding conductors and the methods for connecting to grounding electrodes. Using the proper fittings and connectors is also important for maintaining a secure and reliable electrical connection. Ensure that all fittings are listed for their intended use and are compatible with the type of conduit being used. When pulling wires, use a suitable pulling lubricant to reduce friction and prevent damage to the conductors. Follow the manufacturer's instructions for applying the lubricant. Consider using a wire pulling grip or basket to securely attach the conductors to the pulling rope or tape. This will prevent the conductors from slipping or becoming damaged during the pull. When working with aluminum conductors, use an antioxidant compound to prevent corrosion at connections. This will ensure a long-lasting and reliable connection. Use a torque wrench to tighten connections to the manufacturer's specified torque. Over-tightening can damage the connector, while under-tightening can result in a loose connection. Always energize the circuit before working on any electrical equipment. Use a voltage tester to verify that the circuit is de-energized before proceeding. Wear appropriate personal protective equipment or PPE, including safety glasses, gloves, and a hard hat. Regularly inspect your tools and equipment for any signs of damage or wear. Replace any damaged tools or equipment immediately. Consider the ambient temperature when selecting conductors and determining their ampacity. High temperatures can reduce the ampacity of conductors, so it may be necessary to use larger conductors or adjust the circuit breaker size. Follow the NEC guidelines for derriting conductors when multiple conductors are installed in a conduit. Derriting factors are provided in Table 310.15b3 of the NEC. When installing conductors in underground conduit, ensure that the conduit is buried at the proper depth, as specified in Table 300.5 of the NEC. This will protect the conduit from damage and ensure that it is not disturbed by digging or other activities. Use warning tape or marking to indicate the presence of underground conduit. This will help prevent accidental damage to the conduit during future excavation work. When installing conductors in wet locations, use conductors that are listed for wet locations, such as THWN or XHHW. These conductors are designed to withstand moisture and prevent corrosion. When splicing conductors, use approved splicing methods and materials. Wire connectors should be listed for the size and type of conductors being spliced. Insulate splices properly to prevent short circuits and ground faults. Use heat-shrink tubing or electrical tape to insulate the splice. When installing electrical equipment, such as panels and disconnects, ensure that they are properly grounded and bonded. Follow the manufacturer's instructions for grounding and bonding the equipment. Use a grounding electrode system that meets the requirements of Article 250 of the NEC. This may include a ground rod, ground ring, or other approved grounding electrode. When installing electrical equipment outdoors, ensure that it is rated for outdoor use. Outdoor rated equipment is designed to withstand the elements and prevent water from entering the equipment. When installing electrical equipment in hazardous locations, use equipment that is listed for the specific hazardous location. Hazardous locations are classified according to the type of hazardous material present and the likelihood of an explosion or fire. When working with high voltage equipment, use extreme caution and follow all safety procedures. Only qualified personnel should work on high voltage equipment. Use appropriate high voltage test equipment to verify that the equipment is de-energized before working on it. Wear appropriate high voltage personal protective equipment, including rubber gloves and sleeves. Regularly inspect electrical systems for any signs of damage or deterioration. Repair or replace any damaged or deteriorated equipment immediately. Keep electrical panels and equipment clean and free from obstructions. This will help prevent overheating and ensure that the equipment operates properly. Develop and implement a comprehensive electrical safety program. This program should include training for employees, regular inspections, and procedures for safely working on electrical equipment. Follow all applicable electrical codes and standards. These codes and standards are designed to ensure the safety of electrical installations. Regularly review and update your electrical safety program to ensure that it is current and effective. When terminating conductors, ensure that the insulation is properly stripped and the conductor is inserted fully into the terminal. Tighten the terminal screws to the manufacturer's specified torque. Use a torque screwdriver to ensure that the screws are tightened properly. When installing cable ties or straps, do not over-tighten them. Over-tightening can damage the insulation of the conductors. When running cables through walls or floors, use appropriate cable bushings or grommets to protect the cables from damage. Secure cables properly to prevent them from sagging or becoming damaged. Use cable supports or hangers to support the cables. When installing data cables, follow the manufacturer's recommendations for cable routing and termination. Avoid running data cables near sources of electrical noise, such as fluorescent lights or motors. Use shielded data cables to reduce the effects of electrical noise. When installing fiber optic cables, handle the cables with care to avoid damaging the fibers. Do not bend the cables excessively or subject them to sharp impacts. Use appropriate fiber optic connectors and termination tools. When testing electrical circuits, use a calibrated test instrument. Ensure that the test instrument is properly grounded and that it is set to the correct range. Follow the manufacturer's instructions for using the test instrument. When troubleshooting electrical problems, start by checking the simplest things first, such as the circuit breaker or fuse. Use a systematic approach to troubleshooting and document your findings. When making electrical repairs, use only approved parts and materials. Do not attempt to repair electrical equipment unless you are qualified to do so. When in doubt, consult with a qualified electrician. Always keep safety in mind when working with electricity. Electricity can be dangerous, so it is important to follow all safety precautions. By following these guidelines, you can ensure that your electrical installations are safe and reliable. Use a megameter to test the insulation resistance of conductors. This test can help identify damaged or deteriorated insulation. Use a ground fault circuit interrupter or GFCI to protect circuits that serve wet locations such as bathrooms and kitchens. GFCIs can detect ground faults and quickly shut off the power, preventing electrical shock. Use arc fault circuit interrupters or RFCIs to protect circuits that serve bedrooms and other areas where arc faults are more likely to occur. RFCIs can detect arc faults and quickly shut off the power, preventing fires. Use surge protectors to protect electronic equipment from voltage surges. Surge protectors can help prevent damage to computers, televisions, and other sensitive electronic equipment. Use timers or photocells to control lighting and other electrical equipment. Timers and photocells can help save energy by turning off lights and equipment when they are not needed. Use occupancy sensors to control lighting in areas that are not always occupied. Occupancy sensors can turn on the lights when someone enters the area and turn them off when no one is present. Use dimmer switches to control the brightness of lights. Dimmer switches can help save energy and create a more comfortable lighting environment. Use energy-efficient light bulbs, such as LED or compact fluorescent lamps or CFL. Energy-efficient light bulbs use less energy than traditional incandescent light bulbs. Use smart thermostats to control the temperature in your home or office. Smart thermostats can learn your preferences and automatically adjust the temperature to save energy. Use a whole house energy monitor to track your energy consumption. A whole house energy monitor can help you identify areas where you can save energy. Have your electrical system inspected by a qualified electrician on a regular basis. Regular inspections can help identify potential problems before they become serious. Keep your electrical panel labeled and up to date. This will make it easier to identify circuits and troubleshoot problems. Store flammable materials away from electrical equipment. Flammable materials can ignite if they come into contact with hot electrical equipment. Keep electrical cords in good condition. Replace any cords that are frayed or damaged. Do not overload electrical outlets or circuits. Overloading can cause the circuit breaker to trip or the wiring to overheat. Use extension cords only temporarily. Do not use extension cords as a permanent wiring solution. Unplug electrical appliances when they are not in use. This will help save energy and prevent electrical fires. Teach children about electrical safety. Make sure they know not to play with electrical outlets or cords. If you see a downed power line, stay away from it and call the utility company. Downed power lines can be extremely dangerous. If you smell burning plastic or see smoke coming from an electrical outlet or appliance, turn off the power and call the fire department. Electrical fires can be very dangerous. Never pour water on an electrical fire. Water can conduct electricity and make the fire worse. Use a fire extinguisher that is designed for electrical fires. Follow all safety instructions when using electrical equipment. Read the instruction manual before using any electrical equipment. If you have any questions about electrical safety, consult with a qualified electrician.